Hiya. So today we'll be looking at the problem letter combinations of a phone number. This is a medium Leetcode problem and it mainly involves two concepts, backtracking and string manipulation. So the problem statement says that we are given a string containing digits ranging from 2 to 9 and each digit is mapped to a certain set of characters. For example, 2 is mapped to ABC and 3 is mapped to DEF. We have to return all the possible set of characters that the entire string will represent. For example, if we have 2 we have 2 and we have 3, we know that 2 is mapped to A, B, C, whereas 3 is mapped to D, E, and F. What we have to do is we have to return all the possible combinations between these. So we have A to D, we have A to E, we have A to F. Similarly, we have B to D, B to E, B to F, right? And so on. So for example, A to D, this combination will result in AD. Then we have AE, then we have AF, BD, BE, BF, and so on. So this is a combinations problem. So this A is 2 is mapped to 3 options, 3 is mapped to 3 options. So overall we will have 3 cross 3 combinations and that is 9. Even if you see here we have 9 uh, outputs in the entire output array. So if we have, let's say, 3 character length string 2, 3, 4, in that case what will happen is we will have 3.3.3, which is 27 options. So yeah, how will we approach this problem? So first thing we have to understand is, let's say if we have a character of size 1, let's say we have 3. We know that 3 has 3 options, right? Uh, so we know that 3 has 3 options, D, E, and F. So we can represent that. We can take D, we can either take E, we can either take F. And all 3 of them combined forms our output. But what happens when we have 2 characters, 2 and 3? This is where things get a bit interesting and kind of complicated. So suppose if we have 2, 3, what we need is we need to process them one by one. And the order of processing is important because 2 precedes 3, right? So 2 comes first and then we'll process 3. So let's say we want to process 2. So what are the options in which 2 can get processed? Now 2 has 3 options, right? A, B, and C. So let's write that. We have A, we have B, and we have C. Suppose we want to take this path. We want to take the first path. So let's say we assumed that the first character is mapped to A. What is the second character? Now we have to process 3. Now 3 again has 3 options, the same options which we looked here. So we will either have D or E or F, right? So this is D, this is E, and this is F. Again, we'll make an assumption. We'll say that, okay, let us take this path. Initially, we took this path. So we assumed it was A. Now we are assuming it was D. What is the output in here? The output is AD. Okay. Do Now we have processed 2. We have also processed 3. Do we have any more characters to process? No. So what do we do when we don't have any more characters to process? This is where the idea of backtracking comes in. So we saw that we have AD. We don't have any more characters to process. This is a dead end. So in this case, we will revert the string which got added. So now D got added to this particular string A, right? So since we don't have any more characters to process, we'll return here. And also after returning, we will revert the state back to its previous state. So we added D and we are removing D. So the state again becomes A. Now we will take the next path, that is AE. We went with AE. We saw that AE has no options further. So we will revert AE back to A, right? We added E to our A, we reverted it. Now the string is A again. We will add F to it in this path. F has no more options, so we revert it back to A. Now that we have processed all the options for the character beginning with A, we will also revert it back to an empty string, and that happens here. Now the same processing continues for B. The B's options are considered B, D, E, and then B gets reverted back, then the similar suit follows for C. So this path, right, where we are essentially like reverting, and also this path, this is on a high level called backtracking, right? So in this problem, there are a couple of main caveats. One is we make choices at each level. Second is uh, after a particular choice is exhausted, we revert. So with these two caveats in place, what I wanted to emphasize is If we make choice at each level, this is a fair indicator that this problem will involve recursion, right? And if we are making any reverts, right, we usually can assume that this problem can involve some kind of backtracking. There's also a way to avoid backtracking and just use plain recursion for this problem, but that's beyond the scope of this video, so I'll not discuss it. But yeah, usually one more caveat is recursion, backtracking, and dynamic programming. They're all very closely interwoven. So sometimes we say that backtracking is a subset of recursion. It's just a technique where we focus on the revert operation, whereas DP is also a subset of recursion, wherein we focus on memoization and avoiding repeating work. Anyways, in the scope of the problem, that's a bit of an extraneous information. So let's jump to the code. All right. So for the solution, what I want to do is I will create the return type object and I'll call it result, which can be an array list. And also, I want to create a method called solve, which basically will do the recursion for us. Now, solve will have to accept a couple of arguments. So if you see here, at each recursive step, we are passing around the intermediate state, uh, which is nothing but a string. We have a string here, we'll have a string here, we'll have a string here, and we will have to basically manipulate them. So in Java, if we just use plain string, adding and removing characters from it makes it a bit difficult. So we'll use a string builder instead, and that can be named as current. And we need a indicator which will tell us when we are out of bounds. So if we maintain a variable that indicates which level we are at, as soon as we exceed this level, if as soon as we reach here, we know that we have gone out of bounds. So to do that, I'll just use an integer called start index, naming it si. Okay, nothing but it stands for start index. So this is the method signature. Uh, Also, we need this particular digits to be accessible within the solve method. Either we can pass it as an argument, but I'd prefer it if it's just stored as an attribute in the class, and then we can just assign it. So we'll just say this dot digits is equals to digits, and we will have to call the solve method. We need a new string builder. Initially, it will be empty, so that's why the string builder is empty, and we'll start with 0. So now that we have handled all the other part, let's start with our solve method. So for any recursion based method, the first thing which we should always address is address the base case, right? What is the base case in our approach? This is the base case, right? As soon as we don't have any more characters to process, we will have to do some processing. So what will happen is, as soon as we get AD and we don't have any more characters to process, we will terminate the recursion. But while terminating, we should also ensure that this AD, whatever we have computed here, that gets stored in a result array, right? So we will do that in our base case. So if we are out of bounds, that is if si is greater than equals to digits dot, then, and we know that we are out of bounds, so all we need to do is we need to add that particular current string to our result. So we have handled the base case. So let's handle the recursion case. So to handle recursion, what we are doing, let's say we are at B, right? What we need is, we need two options. We need the number of characters that is mapped to the next character, which is 3. So if we can get those characters, that is in this case it will be D, E, and F, we will add them one by one to the existing character and then continue the processing, right? So to represent that, I'll just use a for loop. I'll have a variable called choice, which comes from get choices for the current string, which is digits dot char at the start index. And for each choice, what I will do is I will append that choice to my current string. So if I had BD, I'll have B plus D, so that becomes BD, and then I'll continue the processing. And after my processing is done, I'll remove D from B. So first I will append. So what that will look like is current dot append choice. Then I'll continue recursion. So that will look like solve current, and we'll have to move on to the next characters, that is si plus 1. And now we will do the backtracking. So current dot delete character at current dot length minus 1. So we have done the backtracking. So with this, I think the approach for the recursion method is also completed and our solve method is also completed. As you can see, it's a very short code. So if all our solve is processed, we can just return the result straight away. Oh yes, I forgot almost. We need to implement this get choices method. So let's implement that. So get choices can return a character array and which will accept a particular character. Okay, let it accept a character reference called key. What it will do is, in interest of time, I have I have copied the mappings. So the mappings are copied here. These are nothing but, for each character, what are the possible options. So get choices will do nothing but to return choices dot get key, and then it will convert it into a character array. We need an array because we want to be able to loop through it, and that gets written in get choices. So if we run it now, we are encountering an edge case. Yeah, so one thing we have to always do is we are allowed to return in the base case, otherwise the recursion will keep running. That's why we were getting this sort of bomb. So if we run it now, yeah, it's passing for 3, and it will pass for this. And this can be considered as an edge case. So in here, if digits dot length, if it's 0, then you just return res directly. Okay, we cannot return it here, so we'll just return here and then yeah, so this works. So yeah, let's submit this code. This should work. So yeah, this concludes my videos, guys. This on a high level is the entire solve method. Thanks for watching. If you have any questions, please leave a comment below. I'll try to address it.